The ocean is vast and mysterious, a realm teeming with life, from the tiniest plankton to the largest whales. But have you ever stopped to wonder what makes seawater salty? It's a fascinating question that takes us deep into the heart of ocean science. The answer lies in a word: salinity. Salinity is simply the amount of dissolved salts in a body of water. These salts are primarily sodium chloride, the same compound as table salt. We measure it in parts per thousand, or ppt. This unit helps scientists understand the concentration of salts in different water bodies. The ocean's average salinity is about 35 ppt. This means that in every kilogram of seawater, there are approximately 35 grams of dissolved salts. This salinity level is crucial for marine life, influencing everything from buoyancy to the water's freezing point. Where do these salts come from? The journey of these salts begins on land. Over millions of years, rain has eroded rocks and carried dissolved minerals into the sea. These minerals include various salts that accumulate in the ocean. Volcanic eruptions, both on land and beneath the waves, also release dissolved salts. These eruptions contribute significantly to the ocean's salinity. These processes, over eons, have given the ocean its characteristic salty taste. The continuous cycle of erosion and volcanic activity ensures that the ocean remains salty. But salinity is not uniform throughout the ocean. It varies from place to place, influenced by a delicate balance of factors such as evaporation, precipitation, and freshwater inflow. Ocean currents, temperature, and the melting of polar ice also play a role in this variation. These factors create a dynamic and ever-changing marine environment. Understanding these factors is key to comprehending the complex workings of our planet's largest ecosystem. The study of salinity helps us appreciate the intricate balance that sustains marine life and influences global climate patterns. One of the most significant factors affecting ocean salinity is evaporation. As the sun warms the surface waters, water molecules gain energy and escape into the atmosphere as water vapor. This process, evaporation, leaves behind the dissolved salts, increasing the salinity of the remaining water.
Imagine a shallow pool of seawater left to bake under the scorching sun. As the water evaporates, the pool shrinks, and the remaining water becomes saltier. The same principle applies on a much larger scale in our oceans. Areas with high evaporation rates, such as the subtropics, tend to have higher salinity than areas with lower evaporation rates.
While evaporation increases salinity, precipitation and freshwater influx have the opposite effect. Rain, snow, and melting glaciers all contribute fresh water to the ocean, diluting the concentration of dissolved salts and lowering salinity.
Think of adding a pitcher of fresh water to a bathtub full of salt water. The fresh water mixes with the salt water, reducing the overall saltiness of the bath. Similarly, regions of the ocean that receive significant rainfall or freshwater runoff from rivers tend to have lower salinity.
Rivers play a crucial role in regulating ocean salinity, a delicate balance essential for marine life. They act as conduits, carrying rainwater and melted snow from land to sea, traversing diverse landscapes and ecosystems. As rivers flow over rocks and soil, they dissolve minerals, adding to the ocean's salt content. This process is a natural part of the Earth's water cycle. However, the vast volume of freshwater they discharge has a more significant diluting effect, especially near river mouths and estuaries. This dilution is crucial for maintaining the balance of salinity in coastal waters.
Imagine a constant stream of fresh water pouring into a salty lake. This continuous flow helps to moderate the salinity levels, creating a unique environment. Near the point where the river enters the lake, the salinity would be lower due to the influx of fresh water. This area becomes a dynamic mixing zone. This mixing zone, where fresh water and salt water meet, is known as an estuary and is a vital habitat for many marine species. Estuaries provide a rich, nutrient-filled environment that supports diverse wildlife, from birds to fish.
Section 5. Ocean currents, stirring the pot. In this section, we delve into the fascinating world of ocean currents and their significant impact on our planet.
Ocean currents act like giant conveyor belts, constantly circulating water around the globe. These currents are driven by various factors, including wind, water density differences, and the Earth's rotation. These currents play a crucial role in distributing heat and nutrients, but they also influence salinity patterns. By moving warm and cold water across the oceans, they help regulate the Earth's climate and support marine ecosystems.
Warm currents originating in tropical regions tend to have higher salinity due to higher evaporation rates. This process leaves behind salt as water vapor rises into the atmosphere. In contrast, cold currents flowing from polar regions typically have lower salinity due to the melting of ice and lower evaporation. The influx of fresh water from melting ice dilutes the salt content in these areas.
Imagine stirring a cup of coffee after adding sugar. The act of stirring helps to evenly distribute the sugar throughout the liquid. The swirling motion of the spoon helps distribute the sugar evenly throughout the coffee. This simple analogy illustrates how ocean currents work to mix different water masses. Similarly, ocean currents help mix water masses with different salinities, preventing extreme variations in salt concentration across the globe. This mixing is essential for maintaining the balance of marine environments and ensuring the health of oceanic life.
Section 6. The invisible hand. Air pressure and wind. While less obvious than other factors, atmospheric pressure and wind direction also influence ocean salinity.
High-pressure systems are associated with clear skies and calm winds, leading to increased evaporation and higher salinity. Conversely, low-pressure systems bring clouds, precipitation, and stronger winds, which can lower salinity.
Think of a windy day at the beach. The wind pushes surface waters away from the shore, causing deeper, colder, and less saline water to rise to the surface. This process, known as upwelling, brings nutrients from the depths, supporting a rich ecosystem. Section 7. A warming world, the uncertain future of salinity. Climate change is already impacting our oceans, and salinity is no exception.
As global temperatures rise, evaporation rates are increasing in some regions, leading to higher salinity. Simultaneously, melting glaciers and increased precipitation in other areas are adding fresh water to the ocean, lowering salinity.
These changes in salinity can disrupt marine ecosystems, affecting the distribution and abundance of species. For example, some marine organisms are highly sensitive to changes in salinity and may struggle to survive in areas where salinity levels are shifting rapidly. Section 8. The global conveyor belt, driven by salt. Salinity plays a crucial role in driving the global ocean circulation system, often referred to as the global conveyor belt. This system is a complex network of currents that transport heat around the planet, influencing regional climates and weather patterns. As warm, salty water flows towards the poles, it cools and becomes denser. Eventually, it sinks to the ocean depths and flows back towards the equator, carrying cold, oxygen-rich water. This sinking of dense, salty water is a key driver of the global conveyor belt. Section 9. Conclusion. The delicate balance of salinity. Ocean salinity is a fundamental property of seawater, influencing everything from marine life to global climate patterns. It is a delicate balance maintained by a complex interplay of factors, including evaporation, precipitation, freshwater influx, ocean currents, and atmospheric conditions. Understanding these factors and their impact on salinity is crucial for comprehending the intricate workings of our planet's oceans. As we face the challenges of climate change, it is more important than ever to monitor and protect this delicate balance for the health of our oceans and the future of our planet.